Hello friends, today we have a very interesting topic and this topic is very important according to UPSC examination as well as from this topic there is n numbers of question those can ask during different types of examination. So this topic is strike slip faults. So basically strike, according to Anderson classification, strike slip faults are those faults where we can get the displacement or relative displacement horizontally. So Anderson classified the strike slip fault in which we have sigma 2 is vertical, sigma 3 and sigma 1 is horizontal. So on the stereographic projection we can represent by this nomenclature here. This 2 is representing sigma 2 intermediate stress axis, sigma 1 and sigma 3. Sigma 1 is the principal and sigma 3 is the minor one. They should be horizontal. So here again in this diagram also we can represent this T is the tension and P is the pressure, sigma 2 is at vertical. So this is Anderson classification. So basically in strike slip faults the moment is should be horizontal. Okay, so here we have different types of strike slip faults. So here one is tear fault. Tear fault is a special type of fault in which we have steep vertical fault associated with low angle regional faults. Okay, so they occur in the hanging wall block of low angle faults and accommodate different amounts of displacement, as we can see here, either on the different parts of the fault or between the allochthon and adjacent allochthonous rocks. The example of the tear fault is in Yamuna tear fault in Himalayan region. So that is the Yamuna tear fault. So tear faults are basically steep faults. Okay. Then transfer fault, it is applied two different transfer fault. These are associated basically with the extensional regime, and here the energy replaced from one major thrust to the fault system here. So it is applied two different geometries of strike slip fault in extensional terrain. This one is related with normal fault, that's why this one is the extensional terrain. Okay, they are parallel to the regional direction displacement and mark domains of different normal faults. In the geometry and displacement, they also generate the imbrications also. And due to this tiltness, they form a ramp, though that ramp is known as relay ramp. Okay, so this transfer fault basically associated structure with the regional normal fault. Okay, so then we have another category, that is transform and transcurrent fault. So basically transform faults are the major regional structures. Those mark the boundary of the two tectonic plates. Okay, so as we can see here, this transform fault is associated with the ridge plate boundaries, or we can say the divergent plate boundaries also. And the transcurrent faults here, trans transcurrent faults are regional scale strike slip fault in continental crust. Basically, this transcurrent fault associate in the within the continental crust, not at the boundary. Here, transform fault occur at the boundary. So this is the main difference. Here we have some examples also worldwide. This is San Andreas fault is a right lateral transform fault system. Then we have North Anatolian fault in Turkey. This one is also very famous. Okay. Then characteristics of the strike slip faults. So here first is all the strike slip faults are planar and vertical at the near surfaces. If the cutoff line is parallel to the bedding, then there is no evidence for separation. This is very important point. If suppose that strike slip fault is parallel to the bedding where both are intersect, so we can't get the evidence of the separation. But if the strike slip fault is in oblique direction, or we can say the dip slip direction, so there should be the evidence of the separation. This question is very important, means examiner can ask like that. If suppose that we have a strike slip fault, so what should be the evidence of the separation in the vertical cross section? So if the beddings are parallel, there is no evidences, and if it is oblique direction, it is in oblique direction, then in the vertical cross section there should be evidence of separation. Then we have some more structure, those are associated with the strike slip fault, that is radial structure. Radial structure is basically, okay, so Riddle structure, shear sense, or we can say these are the associated structure. This one is the main thrust or strike slip fault, and riddle structures are associated with synthetically. Synthetically means they always show the direction as the major structure, as the major strike slip fault. They always show that type of shearing. Okay, and this always occurred at the low angle also. So with this we have P structures also. So P shears are synthetic to the main folds, okay, to the main fold, and are oriented symmetrically with respect to the fold from the orientation of the R shear. Then we have one more structure that is known as R dash shear. In R dash shear, what happened? These R dash shears are the antithetic structures, and they always occur at high angle. So examiner can ask about R structure and R dash structure. So always keep remember this R dash structure always associated occurred at high angle, and these are the antithetic structure. These always show the different shear sense as the main shear sense. Okay. Then we have some example from Himalaya also. In Himalaya, we have two major strike slip structure in the western region as well as in the northeastern region. So in western region we have Chaman fault here. This is Chaman fault here. This western region, this Chaman fault mark the boundary between Indian plate and the Eurasian plate here, and this is a left slip fault as we can see here. This one is moving this one direction and this one is moving this direction, and we can say this one is the sinistral type of movement. One more thing I want to elaborate here. If the movement is horizontal, then we can only say left slip movement or right slip movement, or we can say if the movement is left slip means if the observer block, or we can say object block, is moving towards the left from the observer, that is left slip movement. And if the opposite block moving towards the right, as here in the Sangyang fold, moving towards the right, this one is the dextral movement. So always keep one thing in your mind: in horizontal section, when the movement is showing towards the left or right, that is only then we can apply this sinistral movement criteria, dextral movement criteria, or left slip criteria, or right slip criteria. Okay, so Chaman fault is separate the mark the boundary between Indian and the Eurasian in the western region. So this is laying in Pakistan and Afghanistan region. Here we have a Sangyang fault. Sangyang fault is the right slip movement that marks the easternmost boundary of the Himalaya. Okay, so here we have two major thrust example in the Himalaya also. Okay, then identification of strike slip faults. So in strike slip faults we can identify based on the following criteria. In the strike slip fault, lineation always show the horizontal movement. Okay, if we see the lineation, they always show the horizontal movement. Yes, obviously breccia, gauzy type of material we will get, because these are the shallow depth structures. Strike slip faults occurred within the 15-kilometer depth in the crust. So that's why these are steep in nature. Okay, steep and mostly linear in nature. That's why. Then steeply dipping, this is another characteristic. Straight or gently curved. Okay, then linear erosion depression. We can get the linear erosional depression along the strike slip faults also. Then we can get sag pond, springs, and offset stream, as we can see here. Scarp, this is the vertical escarpment along the strike slip fault. Then we can get springs also because they intersect the strike of the strata. Then linear ridges, then Sutter ridges. This Sutter ridges is the means where one hill migrate opposite to the with respect to the opposite hill, as we can see here. This one is the Sutter ridge here. So Sutter ridge always occurred in the strike slip faults. Okay, so this question is also very important, means examiner can ask where Sutter ridge associated with normal faults, strike slip fault, or reverse fault. So always remember this Sutter ridge always occurred in the strike slip faults. Similarly, as we have discussed in strike slip fault as well as the normal fault, and this reverse fault and normal faults, uh, we have means this Sutter ridges always occurred in the strike slip faults. Okay, so and strike slip faults also can generate the duplexes, and these duplexes shape of the folds on the vertical section as refer the positive forces as well positive flowers and the negative flowers also. That's depend on the association of the normal fold and the strike slip fold. So this is about the strike slip fold. I hope this video you will enjoy the video and like also. So with this note, I'll be very thankful to you, and I will come with the new video soon.